Welcome to the class on transportation problems in MS Excel. Transportation is a technique of operations research. So transportation is used to find out what is the least cost transportation, least cost of transporting goods from maybe a plant to the point of consumption or from the point of supply to the plant. So here's a typical example where I've assumed that there are 3 plants which is receiving supply from 4 sources. Right? So you can orient it any way you like it. You can have the supply on the row and the plants in the column or vice versa. It doesn't matter. So what we have in each cell is called the unit transportation cost. So how much does it cost to transport 1 unit from plant to, how much does it cost to transport 1 unit from supply center 1 to plant 1? Cost is 4 per unit, whatever that unit is. Then what is the cost of transporting 1 unit from supply center B to plant 1 is 7. Similarly, what will be the cost of supplying 1 unit from supply center C to plant B is 4. And what is the cost of what's the cost of transporting 1 unit from supply center D to plant 3 is 4. So this is basically what is called the transportation cost matrix, which is the basis on which we minimize the cost. So we try to find out what will be the allocation of both the demand and supply so that the cost is minimized. So here I've imposed the demand. I have hypothetical values of demand. Plant 1 has a capacity of 100 units. Plant 2 has a capacity of 120 units. And plant 3 has a capacity of 150 units. So this will be their actually demand for raw material. And the raw material comes from 4 sources. That is supply source A, B, C, and D. In quantities 100, 170, 100. So when you total up the total demand, it comes to 100, 220, 270, 370. So you total up the supply also, you get 100, 300, 370. So it's a balanced transportation problem. It's a balanced transportation problem. And we will just show how this is done in Excel. Okay, so here is a problem. I'll copy down that problem. I'll bring the problem here. So for your better understanding of how it is. Make it a little bigger so that you'll see the calculation. Okay. So these are okay. So this is factory 1, factory 2, and factory 3. And this will be supply centers. Supply center 1, supply center 2, supply center 3, and supply center 4. And this is, of course, the demand. And this is therefore the supply. And it's a balanced transportation problem. The balanced transportation problem. And we're now going to solve it. It's rather easy to solve it in Excel. And I'm going to go about it. So what first I'll do is I'll just create the same thing over here. Supply center 1, supply center 2, supply center 3, supply center 4, and demand factory 1, factory 2, and factory 3. Okay. So this is my, so I'll put this in another color so that we are clearly able to distinguish two. So this is it, okay? So here we've got the transportation cost, here we've got the demand, you've got the supply. It's a balanced transportation problem, and I'm going to solve it in Excel. So create the same structure of the problem below, and then calculate the row sums by giving the command equal to sum. Calculate the row sum. Okay, equal to sum. And if you want to see what this looks like, it's familiar, it's a sum of this row. And this is the sum of this row. Okay. So I'll remove the arrows. Similarly, do it for the columns. Similarly, do it for the columns. Sum. Right? So equal to, you need a formula, equal to sum. Sum, okay. So sum equal to sum. Okay. And then I'll copy this to the right. I've got the sum. You want to see randomly one. So this is the column sum and this is the row sum. So all the sums have been calculated and placed. Okay, now you've set up the problem and now you're going to solve it. So first and foremost, I should create the objective function. I'll call it objective function. So to get the objective function, I should use the command sum product equal to sum, and I should multiply this matrix of transportation costs with this matrix which will give me the solution. So this matrix here will give me the solution of the problem. So I should do a sum product of that. If you want to just, yeah. So you can just see that. So it multiplies this matrix with this matrix. As you can see, sum product B2 to E4 with B9 to E9. Right? So you got the objective function and you're all set to go. That's all you need to do. Now you're ready set to solve the problem. So you go to data and then you invoke this problem from solver. If solver is not there, you have to invoke it from home. If sometimes the solver won't be there, then already done it. Okay, then once this is set up, I've set this, I've done these totaling, then I go to solve the problem. So what I do is I go to data, I go to solver, and then it's asking me set the objective cell with the objective function. So select this cell. Okay. Then it's asking me, is it a maximization, minimization, or value of all transportation problems or minimization problems? And it's asking me by changing cells. So this is where my solution is going to come. So I click here and this is my changing cells. This is called the changing cells. This is yellow area, which I deliberately marked as yellow so as to identify it. Okay, that's set. Now I'm going to add the constraints. So be very careful when you add the constraints. Okay, one set of constraints, you're saying these cells should be less than these cells. Right. The next is, always start with this, don't start with the other end. These cells, well, if one is less, the other should be greater. Greater than or equal to these cells. Okay. Now you can see here, your changing cells are from B9 to E11. B9 to E11. This is your changing cells. Now your constraints are this value should be less than this, and these values should be greater. So one should be less and the other should be greater for the sake of balancing. You don't forget, before solving it, you should come here, select a solving method, you click on that and you say simplex and you solve. Okay, it says solver found a solution, all constraints and optimality conditions are satisfied. You say okay, and this is my result. This is my result. So it says that 30 units will come from supply source 1 to factory 1 and 70 units will come from supply source 3 to factory 1 and makes up the 100. Similarly, the others. So 20 units come from supply source 2 to factory 2 and 100 units on supply source 4 to factory 4. Similarly, 80 units will come from supply center 2 to factory 3 and 70 units will come from supply. The total cost will be 120,1260. It depends on the units, depends on what units you're considering. And this is called a balanced transportation problem, which we can then have a look at in our presentation. This is how you can easily solve a balanced transportation problem. You just put the results over here, and here are the results. I'm just giving you a kind of this thing to it, and here is the result of our linear programming balanced transportation problem using a balanced transportation problem using Excel. So now you know that that all the quantities have been balanced. So 70 plus 30, 20 plus 80, 70, 100. This way also 100. The problem is solved. But it's not always that you get a balanced transportation problem. For instance, now I've increased this 150 to 250. So now this total will be 100, 200, 370. And this total is 100, 220, 270, 470. Okay, so here this is 370 and 470. There is a difference of 100. where the demand is exceeding the supply. So when demand is exceeding the supply, then you create an extra column to make the supply balance. You create what is called as a dummy column. You create what is called as a dummy column. Okay, that's how it's done. So remember, please see this again. The quantity demanded has increased by 100 units as compared to the earlier one. It was 150, now it's become 250. So demand supply remains the same. And now this becomes an unbalanced transportation problem because the demand is 470 and supply is 370. So what we do is we first create a dummy column. We create a dummy column. Okay, so now 100, 200, 370, 100, 220, 270, 370. So the difference, you enter it over here. The difference, you enter it over here. 100, 100. And then you solve it just like you do any other, the same way we did over there. Now we can solve it using a transportation problem. So I'll just show you how we do it in Excel. This is Vika talking often. Where demand exceeds supply is an unbalanced transportation problem. So what I will do is, I will insert one column here. I'll do the same thing out here. Okay. And I'll create a new variable called a dummy. Why? Because this quantity has become 250. So if you want to see the total equal to sum, this total is 470 and this total, row total, will be 370. So the difference is 100. So I'll insert that difference here and make it balanced. Note there are no coefficients in the transportation cost matrix. Okay. So the dummy comes here also. Right, and I'll put this value 100. And now I'll solve it in the same fashion. I need to augment this. My objective function equal to sum product. This multiplied by this. Okay, close the bracket and end. Because it should encompass the same thing. Okay, but there'll be no coefficients here. But the total I have to, yeah. Now, here what I have to do is I have to put the formula here and the value there. There is 100, here it's only the formula. Okay, and I think that then I'll start solving. I'll go to solver. Changing cells will change. The objective function does not change. The objective function is the same. Changing cells would definitely change. So what I'll do is I'll go to changing cells. Earlier it was here, so now I have to make it up to here. That's my changing cells. All right, close. Then this total should also get augmented. Total is coming only up to here. So total becomes equal to sum. All the columns of the problem should be selected. So I'll do it for one. I just copy it down with a Control D. Row, there is no problem because there's no extra rows. Changing the objective function is now if I trace precedence here, it covers the whole thing. Nothing should be left out. And remove. The row total should also be complete. Yep, column total should also be complete. Right, so I will remove it. And now I will solve. So I go to data, solver, select the objective function, select the changing cells, right? It's a minimization problem. Then I'll add the constraints. First constraint or cancel. So before that, I will delete these. Okay, and then I'll add them instead. So first constraint is all these together. Now should I come up here? Should be less than or equal to all of these. Then add. Then all of these should be greater than. One is less than, the other one should be greater than or equal to all of these. up to here. Okay. Don't forget to change this to simplex and say solve. Okay, it says solver found a solution. All constraints and optimality conditions are satisfied. I say okay, and this is my new problem. This is my new solution. The value becomes 1230. That's my objective function value, and my result is this. I'll write the results over here. I will center it. Now the unbalanced transportation problem has been solved. Now the dummy variable tells you now 50 units of supply will not be available because now your supply is less than demand. Now supply is less than demand. Demand exceeds supply. So obviously so the dummy tells you how much of the demand is unsatisfied. Now plant 1 will process only 100 units. Plant 2 will process a full 120. And plant 3 will process 50 units less. So the dummy tells you how much of the shortfall. So now you'll be probably able to understand how this unbalanced transportation problem works. Okay, this is how the unbalanced transportation dummy variable. Now we can have another situation. Now where supply is more than demand. Here's another situation where I made the supply more than demand. It reduces by 50, so the total becomes 100, 220, 270, and this becomes 100, 200, 300, 370. So there's a shortage of 100 on the demand side. So in which case, now when the demand is greater, then I'll put, because I have to balance it, so I'll add one extra row. Okay, when I'll add one extra row, and this will take the value, the difference 100. So now it will be 100, 150, 170, 270, 370, and 370. Both are 370. So now I made it balanced. Now here's a case where supply exceeds the demand. Here the demand exceeds supply. Now supply exceeds the demand. And we would work it out the same way. So what we do is we just create the same kind of problem and we start solving it. After balancing it like this, we do it the same way like we did over here. Now, I'll first take the solution and the value you can and the solution you get a value of 860 unbalanced. So because it's a less, here is when the number of variables are greater than 30. If it's greater than less than 30, you can use this method. But when the problem has the total number of variables become greater than 30, then you have to use a conventional linear programming algorithm. Okay, so thank you very much.